Let's get started and have a look at this first homework. Again, this is just on 5.1 Riemann sums, so we'll have a look. Okay, so this first one, we have a graph, and it just wants us to read values. It actually does the Riemann sum for you. It just constructs it, and you're basically, I think, just estimating using the graph here. So let's see, maybe I can make this full screen. We probably don't need OneNote yet. So they're doing a right-hand sum here because the top right rectangles are touching the graph. So I think they say consider the graph, reading the values, estimate the area. Well, if we're estimating the area, basically we're just adding together the areas of the four things. So for number one, part A here, the widths are all consistent. That's like our delta x. And there's four rectangles along a span from 0 to 8. So you could think of that as 8 minus 0 divided by the number of rectangles, 4. So our width is 2. So our area here is just going to be 2. And then we want to estimate the heights of each of the four rectangles. So it's not perfect. I don't know. This is 3. We'll call that 3.75. Maybe they want better than that. But the first rectangle, I'm going to say 3.75. And then 5. And then 5.75. And then the last one is at 6. So we want to run that through the calculator. And we'll see if they accept it. It's always difficult when the scale is not super precise and you're supposed to get kind of a precise measurement. So I'm getting 41. We'll see if it likes that answer. And again, notice that the rectangles are adding these extra pieces above the red curve. So we know that at least the area is going to be higher. And 41. So I don't know what the easiest way to check that is. I think go all the way to the bottom, submit answer. B and C look like they're going to be similar to me, but I'm just curious how well my guess worked for 41. Okay, so it took 41. So you're going to encounter the same sort of thing here. Your width is still 2, and then you're estimating the heights, and this will be an underestimate for B. And for C, you just have more rectangles. This time the width looks like 8, or the width looks like 1, and there's 8 rectangles. So that's it for number 1. Are we having any questions there? Anybody in the chat got anything to say? No. All right, well, let's continue onward. So for number 3, they have the function 3 over x, so we can actually get it exact. We don't have to just rely on a graph this time. So for approximations and endpoints, so right endpoints they say here, so we know it's right. So the right corner should be touching the graph, and we're going from 1 to 5. So this is the only graph with the right corners touching. So we know it's number, or part, I guess, choice A. Now let's go ahead and do the Riemann sum. So for number 2, our function f of x is 3 over x from x equals 1 to x equals 5. So they have the picture for us. First thing, delta x here. Delta x is 5 minus 1 over 4, which is 1. Also, I guess we should maybe say at the top, it's 4 right rectangles. Excuse me. So now we basically just get the area from that. So it's 1, and then we do, oh, we forgot to make the interval. So let's make the interval before we do the area computation. So the interval I mean, it's pretty straightforward. Start at 1, then 2, 3, 4, and end at 5. So for the right rectangles, remember we're using these last 4 numbers. So our area is the width 1 times 3 over 2 plus 3 over 3 plus 3 over 4 plus 3 over 5. So I get 3.85. See if, yeah, the next part is just left endpoint, so that'll be the same. Again, we can see that this is going to be an underestimate here. So let's have a look. Yep, and we got it right. So pretty straightforward there. Number 3 here, we have a similar ordeal. They want us to do 3 right rectangles, then 6 right rectangles. B is probably left rectangles. Yeah, so again, we'll do part A, and I'll leave part B to you. Oh, they actually have midpoints here as well. So maybe we'll do midpoints. I'll do M3. So one of the problems with this is there's so many pictures, it makes the question look really long. So we got to do a lot of scrolling. Anyway, let's look at number 3. Similar process. The function's a little more complicated this time. So we have, let's start with the first one, 3 right rectangles. Actually, we did right for last time, so why don't I do the part B? Let's do the left rectangles. I mean, it's not much different. It's just which points you use, but let's do the 3 left rectangles. Our function is 8 plus 2x squared from x equals -1 to x equals 2. So let's scroll down to that one, select the picture first. So the left endpoints, left corner should be touching. That looks like, well, the problem is that it's not touching at -1 there. So it looks like this first choice, top left corner, top left corner, top left corner. So it should be this one. Let's go ahead and try and figure out this number now. So if we do our delta x, that's again going to be pretty easy here. 2 minus -1 over 3. That gives us a width of 1. So our rectangles start at -1. We have 0, 1, and 2. So that's our partition. Now this is a more complicated function. So again, we're going to be essentially the area is going to be this width of 1. And then we're using the left rectangle. So we're going to be using these 3. So we're going to want to do f of -1 plus f of 0 plus f of 1. So I'm just kind of separating those out. That way we can do them in our calculator separately. So if you do f of -1, we're plugging -1 into this function up here. The f of x equals 8 plus 2x squared. That's going to be 8 plus 2 times -1 squared, which is +1. So f of -1 comes out to 10. F of 0 just makes the 2x squared term go away. So f of 0 is 8. And f of 1 is also 10. You can actually kind of see that just from looking at the graph too. You have 10, 8, and then 10. So that comes out to 28. So we got 28 for L3. I also promised you I would do a midpoint one. So why don't we do M3? So this is part B. Part C, we'll do 3 midpoint rectangles. All right, so we just have to adjust the partition there. So we have -1, 0, 1, and 2. So we actually care about the midpoints on each one. So we care about these three middle lines, which are going to be -0.5, 0.5, and 1.5. So our area formula gets adjusted a bit. We're now plugging in those middle points into our function. So it's going to be f of -0.5 plus f of 0.5 plus f of 1.5. So, well, I guess we don't need a squiggly. We're not approximating yet. So multiplying by 1 doesn't do anything, so I'm just going to evaluate each of these. So what are we're going to have 8 plus 2 times -0.5 squared. So squaring that gives 0.25 times 2 is 0.5, so we should have 8.5 plus 8.5. And then 1.5 squared is 2.25 times 2 is 4.5 plus 8 should be 12.5. So we have 17 plus 12.5, which should give us 29.5. So a little bit more. This is probably more accurate. I guess we also want to select the picture. The should be hitting the middle of each rectangle, so it looks like the second choice here. Let's go ahead and check this. So looks like we got B right, and we also got C right. So both are correct so far. So let me stop and ask if there's any questions from anyone. Can you go over B for number 1? It said your estimation was wrong. We can look. So back to number 1, B. That's just using the graph. Again, like I said, it can be a little bit tricky, but I don't know. So the width was 2 for each of these. And then I would say the heights are going to be 2, 3.75, 5, and 5.75. So I'm just going to do that in my calculator real quick. So I do 2 plus 3.75 plus 5 plus 5.75, and then I multiply the result by 2. I'm getting 30. Check that. So it worked for me. Any idea what your error was? So it says check your questions, mine are not the exact same. Well, everyone's going to have different numbers on their questions, and the functions might be slightly different, but they should be the same types of questions.
I have a question.
Yes, go ahead.
So can you say real quick how you know whether your estimate is higher or lower than the actual area? How did you know which one to pick?
So usually you can tell from the graph. So what we're really trying to do is so the goal is to try to find the area under some curve, right? Something maybe that looks like this, right? From one point to another point. So the exact area would be figuring out this perfect shaded amount. But what we're really doing is estimating, right? So we're estimating from this point to this point. So if I'm using left rectangles here, notice how the rectangles are going above the curve. You've got a little bit extra on this left estimate. So this left sum here would be an overestimate, right? Because you're essentially shading in more stuff than the true value of the curve. Whereas if you did a right-hand sum picture here, from here to here, let's say, you'd be undershooting it because your rectangles always are parallel to the x-axis, right? So you've got little gaps that are missing. So the right sum would be an underestimate here. And eventually, once we learn how to do integrals for lots of functions, this would represent up here the exact area. So using these sums is a way to estimate the exact area, but it's not going to get it exactly right. For your midpoint, you won't know exactly whether it's an underestimate or overestimate. It should be a little bit closer than the left and right. That's why in the lectures when we were doing left and right, we would average them together to get like a closer average to the area. So does that answer your question about when it's an overestimate versus an underestimate? So what about the people that had problems? Were they able to get number one correct? Or at least check that their numbers were a bit different? So it looks like Morgan said she just used the wrong numbers, so that's good. Let's just able to get that sorted out. Matt, I'm still a little curious if yours were just different numbers than mine. Okay, number one was correct. Good. Okay.
Hey, Professor.
Yes.
So just to make sure I got it. So that means number 2A for it will be an underestimate.
So let me look at mine and I'll double check. So is this on a pop out? So 2A, there's number one. 2A, yeah, so we were doing right rectangles. So our picture was A, we got gaps. Notice the rectangles are all falling below, so you've got little gaps. So that's an underestimate to the exact area.
Okay, I got it.
Okay, good. Yeah, I mean, things work out really nicely when it's like an increasing or decreasing function. So if it's decreasing and we had right estimate, it's going to be an underestimate, and left would be an overestimate. And for an increasing function, things would exactly reverse. So an increasing function, your right-hand sum should be an overestimate, and your left-hand sum should be an underestimate. So you can kind of find patterns in there, but usually if you look at the graph, it's pretty easy to tell. All right, let's go back. A few more to look at. Let's look at number 4. Okay, this is just looking at whether or not these are signed areas. So, okay, this is saying 0 to 4. So really what we're going to do here is we're just going to kind of shade things. So for number 4 here, remember this integral is just telling us essentially where to shade between the curve and the x-axis. So we have this general picture, that looks something like, I don't know, I'll try and approximate it. And then this would be 10 where it finishes. The curve is doing, I don't know, one of these. Something like this. This is g of t. So for A, they want us to do the integral from 0 to 4 on g of t dt. So basically, we're just going to try and draw the picture and shade what we're doing. So if we have this graph, and this is 6 and 4 somewhere over here, and then, we've got 10 over here, and our curve is doing this. Basically, the area we're looking at is shading from 0 to 4. So we'd just be shading this region. That would be exactly what the integral represents. So that is a positive area because it's above the x-axis, and we're going from left to right. So we know that this one is positive. If we did 6 to 8, if we thought about 6 to 8, where would we be shading?
Negative.
Yeah, it would be negative. Very good. 6 to 8 g of t. We're below the x-axis, so we're negative. So let's just quickly kind of draw the picture. You can visualize it in your head, I'm sure, but it's good to kind of do it as well. So we're doing something like this. So we're shading from here to somewhere in here. If this is 8, so we'd be shading this region. And we're going from left to right, so this is negative. So below the x-axis, so we could say positive here and negative down here. So we get negative. 4 to 10, we're going to have to do a little bit of a comparison, right? Because we've got a negative and a positive region there. So we're doing 4 to 10, g of t dt. So we get our picture again. So we've got 6, 4 is somewhere here, and then 10 is all the way over here. So we do this ordeal, something like this. So we've got two portions here. We've got this one, and we've got this one. So this part's positive, but this part's negative. But it looks to me like, so negative part seems larger than the positive part. So a total net negative change, let's say. Does that make sense? It's almost like the old expression, right? 1 step forward, 2 steps backward. You did move forward at one point, but you overall experienced a net negative because you ended up going backwards. So that's kind of what this integral is like. So I would say negative. It's kind of hard for us to see 0 here because for it to be 0, we usually have to see some kind of symmetry because these are kind of amorphous shapes. 0 to 8, 0 to 8, I'm not going to draw this one, but you can see that 0 to 6 part is a huge positive part, and 6 to 8 is kind of a small negative part. So this is as well going to be an overall net positive. Okay, so pretty straightforward there. Any more questions? All set? All right, good. Don't see any. This looks similar to my eyes right now on number 5. All regions look the same size. Does it say? Yeah, so if you read up here, it says all regions have an area of 3. So find the value of each. Okay, so if we're going from -4 to 0, that region A is -3. Region B is +3. -3 plus 3 would make 0. So for A, we would get 0. For B, we're going from -4 to 2. So -3 plus 3 minus 3, that would come out to -3. So that one's pretty easy. We just have to read the instructions closely because if you just read them, in a cursory fashion, then you might overlook that the area is exactly 3 there.
Professor?
Yes.
I know you said it was easy, but could you just do it one more time? Like,
Yeah. So okay. Let me just write it down then. So number 5 here, we've got some situation. Were they using negative? So they've got some graph. The numbers don't even really matter. So like -2. This is 0 right here, and maybe +2. Oh, and then maybe like 4. So they've got this region. Oh, it started below. So we got this region, and then this region, and then this region, right? So they literally tell us that the areas of all of these are 3, right? So area of A equals B equals C, which is the number 3, right? But because A is below the x-axis, it's interpreted as -3. B is above the x-axis would be +3, and C below the x-axis would be -3. So I think for part A, they said, let's do the integral. And this curve, maybe they called it f of x. I don't know. So they have the area of f of x dx from -2 to 2. So that would be area, well, it would be the signed area of A plus the signed area of B, right? So it would essentially be the shaded regions A and B. So you could do that piecemeal. So we have a -3 for region A below the x-axis plus the 3 for B, and that comes out to 0. They're just telling us what these areas are. We're not using any math to figure them out. Really, we're just interpreting graphs here. So like for A, we're the picture, if you will, is only looking at shading the first couple of regions, right? So we're only doing this and this, and we're not doing anything with part C. But when we do, B. For B, we're doing the whole thing, -2 all the way to 4. So that's going to be -3 plus 3 and then -3, which comes out to -3. And that's because for this part, we're actually doing all 3. We're shading the entire thing. Because the numbers above and below the integral tell me where to stop and where to start. So this is -2 and this is +2. So this is my start value and this is my stop value. And the same thing down here. This was -2 and this is 4. Because again, this is my start and this is my stop. So did that clarify?
Yeah, I got it now. Thank you.
You're welcome. Okay, so number 6, it looks like we're doing the same thing, but now we've got like some geometry going on, right? We might have to do like a trapezoid or a triangle. We'll see what they throw at us. So, you know, you can do this a number of ways. Lots and lots of ways, really. And it's all how you want to utilize the grid. So for number 6, let's say A. Again, it's going to depend on your numbers, I suppose. That's why I guess I have to draw these pictures. Gosh. You know what I could do? I could screenshot it and then depends on how technical we want to be. Snipping. All right, we'll see how. I just don't want to draw the graph and have it not be precise. So I'll save this. Let's say HW1 number 6. Not sure. Okay, so we can just go over here. Okay, so we have this picture. So for A, we were doing, the integral of f of x dx from 0 to 6. So essentially, what does that look like? That is this first part. So we've got this line that starts at 3 and goes up. So 3, 6, 9. It goes up to 9. And it's 6. So we've got we've got a shape here, right? So we've got this trapezoid shape that we're trying to shade in. That is our area. That's what the integral is. It's just that area. So the area of a trapezoid, I don't know how your geometry is, but it's essentially height times b1 plus b2 over 2. Right? So if you have a trapezoid, typically a trapezoid would look like this, something like this. You have base 1, base 2, and then you've got some height. That's how you would figure out the area. So for this one, we would think about our height. You would have to turn this trapezoid over, kind of rotate it 90 degrees clockwise. So you've got this is 6. You've got a base 1 of 9 and a base 2 of 3. So our area here would be 6 times 3 plus 9 divided by 2, right? So this is actually just 6 times 6, which is 36 square units. That is one way to do it. Is there another way? Well, certainly. Let's think about these little squares on the grid. How big is each square? Each square is 3 by 3. So each entire square represents 9 whole units, right? So if we're looking at this thing, how many entire squares do we have? 1, 2, 3, a half, and a half. So you have 4 entire squares where each square is area 9. So 4 times 9 would be 36. So you would have an area of 36 by counting squares as well. So you can use formulas from geometry, or you could use the squares. You could also divide a trapezoid if you don't want to remember the formula. You can always divide the thing into a triangle and a rectangle, and then just add them up. So in this case, you could have done that. We have a triangle on top and a rectangle on the bottom. And then your triangle area formula is 1/2 times base times height, and your rectangle is just length times width. Okay, so let's see what they ask us in part B. Part B, what did they want? They wanted 0 to 15. 15 goes all the way over here. So again, you could count squares. It's a little bit harder though, because now you've got like tiny little pieces. So let's see what shape this is, 0 to 15. So in this case, we're all the way out to 15. We've got our 3. We know we go up to 9 at some point or something like that. Got the picture here. So we go up to 9, and we're at height 9 from 6 to 9. And then it shoots back down. So again, this is not precise. I'm just trying to get an approximation of what's going on. So we've got this guy. This is parallel to the x-axis, and then we go down to 0. So again, probably this one you just want to divide into pieces, because we're shading the whole thing, right? So maybe I'll call this A, B, and C. Well, we found the area of A in part A, right? So we already know that the area of A is 36. We just did that, or whatever your numbers were, it should be the same as part A. The area of part B, what is that? That is the area of a rectangle. It has a width of 3 and a height of 9. So the area of B is 3 times 9, which is 27. And the area of C is a triangle that is 1/2. The base is 15 minus 9, so the triangle has a base of 6 and a height of 9. So again, that's 3 times 9, so that's 27 as well. So the total area is 36 plus 27 plus 27, which is what, 90? I think 90. So what do we got here? We got 36 and we got 90. Yeah, sure did. All right, let's just try and estimate what is the picture going to look like from 21 to part C is 15 to 21. 15 to 21. That is an upside down rectangle or triangle, upside down triangle. If you look at that, it's this triangle. But it's below the x-axis. So figuring out a triangle is very easy. I'm not going to do that one. Just remember that your answer should be negative. And then going 0 to 27 is doing the whole thing. Again, really, you would just do it in 2 parts. We already had part B. This whole positive area is 90. You would just have to figure out your whole negative area, which is a triangle and a trapezoid. So we've done all the shapes so far, so I think you should be able to manage part C and part D. So give those a try. If you get stuck, we can work on them at the end. I just want to make sure we get to look at 7 and 8 as well. Let me make sure. Any other questions I can answer quickly? Okay, so let's look at this again. Okay, these look tricky, but can anyone answer for me? Well, let me do it this way. So for number 7, it looks really complicated because it's this really hard formula. But the reason it's not, if we think about y equals the square root of 16 minus x squared, maybe you don't recognize what shape that is. But if I squared both sides, I would get y squared equals 16 minus x squared. And then I could add x squared, and I would get x squared plus y squared equals 16. Does anyone know what this graph is? Does anyone know the picture you would get if you would graph that curve? It's actually, anyone got an answer? No. It's from algebra. It's one of the most basic shapes. It is actually a circle, right? This is a circle, graph of a circle. With centered at 0 with radius 4, centered at the origin. Okay, and this would just be the graph of the top half, because it's solved for y, so it's a function. So what do we have? We've got this circle. This is going to be bad, but what's my best circle freehand? So this is positive 4. This is negative 4. So when we're doing the integral from negative 4 to 4 of this square root of 16 minus x squared, really what we're doing is we're trying to figure out this shaded area. And remember, the area of a circle is pi r squared. We're doing a half of a circle, so ours will be 1/2 pi times 4 squared, which will just come out to 8 pi. So 8 pi is our answer for number 7. So I'm going to do 8. I'm going to see if they have a pi symbol over here. Sure do. 8 pi. So there we go. 10, we've got the absolute value. Remember, the absolute value is just the v that goes through the origin. So probably we're just going to have 2 triangles to add up. So number 8, I think it was -1 to 4 of the absolute value of x dx. So if you're graphing y equals the absolute value of x, it just looks like this. So -1 and then 4. So we've essentially just got 2 triangles to add up. So again, this has the first triangle has a height of 1 and a base of 1, and triangle number 2 has a base of 4 and a height of 4. So we'd have 1/2 times 1 times 1 plus 1/2 times 4 times 4. So we'd have 1/2 plus 8. So we'd have 8 over 2 or 17 over 2. Sorry, 8.5 or 17 over 2. So that's number 8. Actually, much easier than number 7, I would say, because you don't have to, make the you don't have the conceptual leap really, because I think most people would recognize the graph of y equals absolute value of x faster than they would realize what the graph of y equals the square root of 16 minus x squared looks like. Okay, so that's it for the homework. Does anyone have any questions that they would like to ask me? No? All right, then. Oh, go ahead.
For number 7,
Yeah.
could I see that real quick? Cause I got a wrong answer.
What's your curve?
My curve?
Yeah. The square root of what?
Square root of 4.
4 minus x squared?
4 minus x squared.
Yeah. So remember, yours would look like x squared plus y squared equals 4, and the general pattern to figure out your radius, if you have, is so the circle.
Yeah, the radius.
The equation of the circle is r squared, so your radius should be 2, if that makes sense.
Okay, yeah, I did that. So far, I did it.
So if you have a and is your integral going from -2 to 2?
Yes.
Okay, so you're still doing the same thing. R squared would be 4 for you, and you'd be doing 1/2. So your answer should be 2 pi.
Oh, 2 pi? I thought
Yeah,
it'd be
1/2 times pi times 2 squared, right? So 1/2 times pi times 2 squared is 4 pi times 1/2, which comes out to 2 pi.
Oh, okay.
But yeah, easy mistake to make. I knew you're probably either forgetting about the 1/2 or squaring it. Any other questions? Okay, if not, then we will end it here. Like I said, I got the first recording done. I'm just working on getting it posted. And I'll try and get this one posted as well. And I guess I'll post the notes too.
Is this something you do with every homework assignment?
I mean, I'm planning on it.
Nice. Okay.
Yeah, and I think I have test reviews and final reviews as well. They should already be on my playlists, honestly.
That's perfect.
Yeah. All right. Well, hope everyone has a nice weekend. And I will see everyone. I think Monday's Martin Luther King Day, right? So we won't meet until Wednesday. Can anyone confirm? Can anyone
Yeah, that's
confirm?
right. When is this
Correct.
homework due?
I think let me look over here on
20th.
yeah, it should say somewhere at the top maybe or on the thing. I think it's the 20th.
Okay. Thank you.
Yeah, up here in the top right corner of the assignment, Wednesday, January 20th by 11:59 p.m. Anyone else? All right, then I will go ahead and end the meeting.